We have the IOCCC Opposite Award.
Yeah, for something completely opposite.
Yes.
And actually taking this trophy back.
No, it's opposite as in the award is opposite, or is it opposite in the previous award? Well, let's see.
Well, let's bring out the trophy.
And the IOCCC Opposite Award goes to Cody Boone Ferguson from the United States.
And here is Cody's fun source code. We have this pyramid of source, and on bounds on top. I called this section here. Maybe this is like a coding table that CSC might climb around on. Maybe a display desk on there. Balance precariously on top of this code. I don't know what was your interpretation of that.
That's Earth.
And it has this comment saying, "I dare you to kind of tweak map of our flat square Earth." Interesting.
Oh.
So moving forward here, this is what the source code looked like formatted, and we have these sort of constants, and then this section here, which is this main there. That moves down, and then we have this other M function. There's end of the main, and here's another M function out there that has some interesting aspects to it. Yeah, I would invite you to look into this code. It has various things about Hollow Earth and other interesting bits. And if we go and look what it does, so here is the program, and you give it two arguments. A latitude and longitude. You give it a ppm image, and it'll produce a ppm image. When you run it, what you're given is the latitude and longitude of the opposite, the antipole of your initial coordinate. So if you want to look at what it produces, here's an example of this thing where you've got this equal rectangular image, and here is the coordinate, and here is the opposite. So not only it places on the map and then gives you the little gradle like thingy there, one's above, one's below, or the pin, however you want to call it. If you, for example, give it the opposite coordinates, and run it on the Earth, you get the opposite. So here you're in China going back to Argentina. There's many examples in this try to sh script. One of them, of course, is the coordinates, approximate coordinates of the center of the Chicxulub impactor asteroid that impacted off the Yucatan Peninsula some 66 million years ago. And that led towards the demise of the dinosaurs. Now, you're given this map of today's Earth, but had you looked at the map some 66 million years ago, you would have found that the Indian subcontinent, not having plowed into Asia and created the Himalayas, would have been down here closer to this antipole spot. There's a hypothesis that said that one of the effects of the impact of the asteroid strike was to splash lots of material up into the air, creating, this sort of winter that lasted for several years, blocking out the sunlight. The other thing was that those shockwaves went around the world and converged on the antipole site. So basically, the shockwaves traveled there. We know that, for example, in this area here, the up in New England, the shockwaves from that impactor the ground was oscillating, a meter up and down from essentially the bang of that. Those shockwaves went around the world, converged on the other side, and the result was a eruption of significant thing on the other side where the things converged. There's a hypothesis that said that some of the volcanic traps, the extensive volcanic traps, were either enhanced or induced into a major eruption, which put further material in the southern hemisphere into the thing, further causing the demise of the dinosaurs. So that's a model. But here's a case of showing you this stuff. There's lots of other little things I invite you to look at and try it on stage. One of them, of course, is this flat Earth thing. So those people that have an incorrect view of the world, here's your sort of flat Earth sky thing. That if you try to then do the coordinates, you get silly, ridiculous stuff because obviously the Earth is not flat; it's a sphere, and this gives you an illustration to show you that flat Earth doesn't really work. There's also, if you take Brian Wesley's 1992 entry, and you can use it to validate the code. It was an ASCII map, and so you see here the coordinate, and you give the opposite coordinate. You can see here for Argentina. So you can use this 1992 entry to validate Cody's code, which does work quite well. Now, there's a challenge. And the fun challenge is this. What you saw was equal rectangular images, and it using equal rectangular map to put points on it. There are other projections. There's Mercator projection, there's polar projection, and so forth. Come up with an alternate version of this program that uses -p projection to have it do the antipoles for a different projection. So see if you can come up with an alternate version of prog.c that would allow you to do a -p projection for some values of various projections. But we need to congratulate Cody for their 6th IOCCC winning entry. Well done, Cody.
And for an alternative challenge, if you happen to be a flat earther, produce a working model.
Yes. Okay. Well done. Let's see what more C we can see.